Hey guys, in this video the brilliant Mr. B is going to be taking you through activity networks. Now this is pitched at GCSE further maths, so level 2, level 3, or you can use this in preparation for your A-level maths, maybe over the summer holidays. In this video he's going to work you through 9 different examples at a nice slow pace, so you can speed up the video if you feel you need to, or you can look at the question, pause the video and then try to answer it yourself. Now, if you want a load more questions to help you revise, to make sure you've properly got this skill sorted, then they are all waiting for you over on my website.
We are going to have a look at activity networks, and these are all about a web of tasks, some of which depend on each other, some don't. So it might be some kind of industrial manufacturing process. Perhaps it's making a car. And, when you're making a car, you can make individual components, but some components have to be fit together. And perhaps you have to wait until some of the components are fit together before you can add something else on. So, for example, when making a car, you have to have the body of the car done before you can put the windshield in. So putting the windshield into the car and all the other windows depends on several other things happening beforehand. So let's have a look at the network. So with these networks, you always start off with 0. So this is 0 amount of time. Now, time in these networks could be in minutes, it could be in hours, it could be in days. So we're starting off with 0 of our time unit. And we have 3 different activities that can happen at the start that are not dependent on anything. And what I'm going to do while we're going through this diagram is I'm going to make a chart to show what is dependent on what. So we have the activities and we have what the activity depends on. So we're going to have a look at activity A first. The activities are represented by arrows, and activity A has a duration of 14. And for argument's sake, we'll just say days. So A takes 14 days. So we can record that in the box at the end of the activity. And we record it in our chart. Activity A depends on nothing. We can do it at the start. And we have activity B. Activity B starts at the start of the diagram. It's got a duration of 9 days. So activity B depends on nothing. And we have activity C that also starts at the start of our diagram. It's got a duration of 10 days. So activity C depends on nothing. So we're going to move on to activity D. Now, activity D doesn't start at the start of the diagram. Activity D starts at the end of A. And activity D has got a duration of 9 days. So we can say about D, activity D depends on activity A. It can't start until activity A has finished. So 14 days for activity A have to have gone by and the activity is completed. Then activity D takes 9 days. So 14 plus 9 is 23. So you can see we're adding up the number of days as we are going. So activity D starts on day 14 and it ends on day 23. Let's move on to another activity. Let's go through in alphabetical order. Let's look at E. So activity E, it starts at the end of activity B. So we can say that activity E depends on activity B. It takes 5 days. So the 9 plus the 5 is going to give us 14. Then we look at activity F. Now, activity F is starting in the same place as activity E does. So they both depend on activity B. E and F can both start once B has finished. Now, F takes 8 days, so 9 plus 8 gives us 17. And before we move on, what's really important here is that you can see that I've highlighted the activities I've done so far because things get a little bit more complicated. Let's look at activity G. The activity G starts at activity C. So we can say that activity G depends on activity C and it's got a duration of 3 days. So 10 plus 3 gives us 13. Now, this is a problem because it's given us 2 possible values for the ends of activity G and F to put on the node there. So do we put in the 17 or do we put in the 13? Well, what we do is we're going to put the 17, so we're going to put the largest value. And that's because we move on to the next activity in that network, which is activity K. So we're not in alphabetical order anymore, but we need to look at K next. Activity K depends on 2 activities. It depends on F and G from happening. So when we are saying, is it 17 or is it 13? We're saying when activity K can start. Now, if activity K started at 13, F wouldn't have finished yet. So it would be like trying to put the windows into a car, like I said before, without the roof being finished and the window's going to fall through. You need the roof done. So you have to put the latest number and the highest number in because while G is already finished at 13, we have to wait for F to finish to start. So we're not going to put in 13, we're going to put in 17. As you can see, I might have had to change my answer there. So make sure you do these diagrams in pencil because you may have to make adjustments. So next we'll look at H. H starts at E. So we can see that H depends on E. Now we know that E also depends on B. So really H depends on E and on B happening. But I'm not going to write in the B because that's already dealt with the activity E's row. And then look at the number. H takes 7 days. So 14 plus 7 is 21. And again, we have two different alternatives. But while we can finish activity H a little bit earlier than D, we have to wait until D's finished to start I. So we'll need the highest number in there. What's left? So let's look at I next. I takes 7 days and it depends on, so the node before it's got 2 arrows going in, D and H. So it depends on both of those. I depends on D and H finishing before it can happen. And 23 plus 7 is 30. One last one to look at. We've got activity J. Now, activity J, it takes 4. So 14 plus 4 is 28. So again, we want the largest number. So we're going to have 30. And for that last box, we actually have the 28 from J. We have the 30 from I. And we have 19 from K. So out of the 3 options, the highest one is a 30. So 30 is going to be our answer. And J, I'm just going to try and squeeze it into the bottom. So sorry if you can't read it. So J depends on E happening. So we have our network filled in with the time values. We have a list of which activity depends on what, and we're being asked for the length of the critical path. Now, we'll talk more about what the critical path is later, but essentially we want to know how long it's going to take to finish everything. And everything is going to be finished after 30 days. We're just looking for the value at the end of the graph for the critical path. Now you might be wondering, why did the diagram with activity and depends on? Well, you might be asked to draw your own network and you'll be given as a question the activity list and the dependency list. So you need to be able to turn the list into the diagram sometimes if you're asked. So let's move on to another example. And again, I'll be making the activity list as we go along. So we need to find the length of the critical path. So we're going to work out all the values going through the diagram. So we always start at 0 at the start. Activity A is adding on 3. Activity B is adding on 12. And activity C is adding on 8. So we can say that activities A, B, and C, they all start at the start, so they have nothing to depend on. We'll go through in alphabetical order. So D adds on 8. So it's adding on 8 to the 3 before it, which is 11. And the 3 is from activity A. Say that D depends on A. Then we have activity H. Activity H adds on 9. So 3 plus 9 is 12. Well, we've already got 12, so that's fine. And activity H, it came from the 3, which is from activity A. Then we have got the E. E adds on 6. So 12 plus 6. 6 is 18. And activity E came from a 12, and the 12 was a result of activity B and H happening. Then we've got activity F that adds on 4. So 8 plus 4 is 12. That's less than the 18. So we'll keep 18 in there. And F came from the 8, which is a result of activity C happening. Now activity G, that's got a length of 6 days. 8 plus 6 is going to give us 14. And the G came from the 8, which came from activity C as well. Now let's have a look at I. I adds on 14, so 11 plus 14 is 25. And I came from the 11, which came from activity D. Then we have activity J, that adds on 3. 18 plus 3 is 21, so we'll keep the 25 because it's larger. And activity J, it came from the 18. Now the 18, again, you look at the number of arrows going into the box. So we've got the E arrow, and we've got the F arrow. So I'm not just going to put E because that's the one that actually gives us 18, because F gives us 12 instead. It's going to be a result of both. So we do include both of them. And the last one is activity K. Activity K adds on 10. 14 plus 10 is 24. So that's smaller. So we will keep 25. And activity K depends on the 14, which came from activity G. So what is the length of the critical path? Look at the number at the end. It's 25. So it was days, it'd be 25 days. It was hours, it would be 25 hours. So let's have a look at one more activity list. So let's look at activity A, B, and C first because they have no dependence. We know that because they all start at the start of the graph, which is 0. A adds on 1, B adds on 9, and C adds on 2. Moving on to D, D adds on 8, so 1 plus 8 is 9, and D depends on the one before it, which came from the A. Then we can look at E. E adds on 3, so 9 plus 3 is 12, and E depends on the arrow before it, which was B. Then we can look at F. F adds on 13. Now, we've got 2, we add on 13, we get 15, and we've got 12 in the box. So let's rub out 12 and replace it with a larger number, which is 15. And F depends on the 2 which came from the C. We look at G. G adds on 5. So 2 plus 5 is 7. G depends on C. Then we can look at K. Now K adds on 6. So 7 plus 6 is 13, so we're 15 safe. And K depended on the one before it, which was G. Note with the K, the direction of the arrow. So it's going from the 7 to the 15. It'd be easy to read it the other way around and go from the 15 to the 7, and perhaps on the 6 to get 21, which is incorrect. So the direction of the arrows is really important as well. Now you'll notice we've got most of the diagram filled in. And what we could do here is that we could say we've got J, which is 6. 15 plus 6 is 21. J depends on E happening, and K and F. So notice there's 3 arrows going into the box with 15. So it depends on 3 things. So we could say, well, job done. We've got the critical path, 21. Write down the answer and finish. But this is the benefit of highlighting each activity. We can see there's 2 that we've not highlighted, and these will change the answer. So activity H is 6. So H depends on the box before it. And again, it's that box with the 15, so it depends on E, K, and F. Now it adds on 6. So 15 plus 6 is 21. So we have to replace the 9 with a higher 21. So if you complete activity D after 9 days, you're going to have to wait another 12 days until you can start activity I, because you have to wait for H to finish. And looking at activity I, that takes 12 days. 21 plus 12 is 33. So we have to change our final answer. It's not 21. It's going to be the higher number, which is 33. And the I depended on the box before it, which was D going into it and H going into it. So the final answer is 33. Let's write that down. So we've covered having our list of activities, the diagrams that they turn into, and going through the diagram to find the length of the critical path, which is the length of everything that needs to finish happening. So now let's move on to something a little bit different. So for the median questions, you might have noticed that there are 2 boxes for each node. And why are there 2? So we're going to have a look at it with this question, find the earliest and the latest start times for a task. So you start off the same way we did before and you fill in the diagram. So start off with 0. And again, it's a good idea to highlight each just in case you have to replace a value, because you might have alternatives. So A is going to be added on 2. D is added on 13, to give us 15. C is added on 3. B is added on 14. E adds on 12. H adds on 2. Now that'll give us 28, which is larger than the 15. So 15 needs to be replaced. And it's this replacement and the alternatives that we're looking at which will be relevant for the earliest and latest start time. So let's look at G next. G adds on 11. But then F adds on 8. So 14 plus 8 is actually 22. So again, we'll replace the value of the 14. This will be important later. K adds on 8, but I can see already that J actually adds on 12, which is larger. So 26 plus 12 will be 38. Now, will I make a larger number than 38? So 28 plus 5 will give us 33. So it looks like 38 is going to be the critical path. So what we're going to do now is we're going to work backwards. And we want to find the latest start times for each task, because in blue, what we have are the earliest start times. Each one of these tasks cannot start until this number. So I can't start until the number before it, 28, has passed. The task hasn't ended until we've got 38. When looking at J, J can't start until the number before it, which is 26. And so for K, the earliest start time for K is 22. And it's 22 because you cannot start task K until F and G have finished. And we've already determined that that's at 22. Now, what about the latest times? So we have to go backwards through the tree and we have to take away. So if everything's finished by 38, we think about task K. If its earliest start time is 22, then 22 plus the 8 for task K means that task K can finish at 30. So there's a whole 8, let's say, hours for the time unit. There's a whole 8 hours where nothing's happening in regards to task K. So what we could do is we could not start K at 22. We could actually wait 8 hours. We could start task K at 30, it would take 8 hours, and we would still finish at 38. So we take away. So we take 38, and we take away 8, and we get 30. And so 30 is the latest start time for task K. Let's look at a couple more. So we can say, that the latest time everything finishes 38, so at this end, it's going to be the same number twice. The task I, we take away 5, 38 take away 5 is 33. You remember we talked about 33 earlier on. So task I, it could start at 28 and finish 5 hours later at 33, or it could start at 33 and finish 5 hours later at 38, and everything will still be done in time. Then looking at J, 38 take away 12 is 26. And you'll notice this box, both numbers are the same. And we'll talk about this later because this shows the critical, but we'll save that for the hard question. So we could go back and do the entire diagram. We'll have more practice on that later. So just focus on the ones at the end at the moment. And so our answer is the earliest time is 22 and the latest is 30. So let's look at another example. So we start at 0. Task A has a duration of 13. Task D has a duration of 1. And task I has a duration of 6. So can we say the earliest start time for task I is 14? Well, we need to look at the rest of the diagram because the numbers we found just targeting I could be changed by some of the other values going in. And we don't know if 20 is actually the critical path or not yet. So let's do the rest of the diagram. C adds on 12 and B 6. H adds on 15 and 6 plus 15 is actually 21. So we do have to change these answers. That means adding on 6 to that is going to give us 27. Now it's a little bit awkward changing multiple like this, so try and work from left to right. If you don't work from left to right, you have to do what we just did here and go back and take several, and that's where you'll start to introduce mistakes. Let's look at E next, give us 16, and F, 12 plus 6 actually give us 18. That's larger than 16. Then we have G adding on 5, that's 17. K adds on 14, and J adds on 14. So it looks like we're a larger value than the 27 potentially. So the 21 plus the 60, the 6 for I gives us a 27, which I think will be smaller than some of the others. We have the 18 plus the 14 for J will give us 32. I think that might end up being the largest one. And the 17 plus 14 for K will give us 31. So it looks like 32 is going to be the value of the critical path. So we want the earliest and latest start times for task I. So task I can start at 21. We know that already. But if the latest that everything finishes is at 32, then working backwards from 32, we take away the 6 for the task I. That's actually going to give us 26. So task I could start at 21, take 6 hours, and end at 27. And then we've got 5 hours left waiting until the end of all the other tasks. Or task I could start at 26, take 6 hours, and end at 32 at the same time as the other tasks. So you've got a range of about 5 hours there from the earliest to the latest to start that task. And that might be relevant because you might have more than one person working on these tasks. So perhaps the person who could do this task might be available a little bit later. And you just want to hold off at 21 hours, maybe wait until 24, 25, 26 hours and wait for someone else to be available to do the task. So you don't need to employ somebody else. And as a follow-up question, what would be the latest start time for D? So what we do is we take the latest start time at the end of D, which is 26, and we take away the 1, and we get 25. So that means that you could start task D at 13 hours. It only takes 1 hour, and then you're waiting around for 9 hours to do something else with whatever the output of task D was. Yeah, perhaps you're making, a car, and it's a component of the car. Maybe you made the tyres, but it takes an hour to make the tyres. They're sitting around for 9 hours doing nothing before they're attached to the car. So what the 25 means is you could wait any period up to 9 hours up until 25 to start doing the tyres because you'll need to be ready by 26. So let's try one more of these. Again, we start at 0, and then we can do the ones with no dependents, A, B, and C. So D takes 13, so 14 plus 13 is 27. E takes 6, which should be 16. F takes 2, so 13 plus 2 is 15. That's smaller than 16, so we're good with 16. G takes 4, which will take us to 17. And K takes 14, so 17 plus 14 is going to be 31. That's higher than 16. Now we've done all the inputs into that box. We'll do the outputs, so we can add on 4 for H, which is 35. And then we can add on 7 for I, which is 42. And then we can add on 4 for J, which is 35, which is smaller than 42, so we don't need to make any changes. Now we want the earliest and the latest start time to task J. So task J takes 4 hours, so it can start at 31, which we've already written in the diagram. Now at the end time, we can take 4 away from 42, and that gives us 38. Now we Can write 38 in the diagram, but let's look at I. I takes 7. So 42 take away 7 is 35. And then H takes 4. And 35 take away 4 is 31. So we have two different alternatives for that node for the latest time. Now, although in many cases the nodes do represent the earliest and latest start times of tasks after it, they don't always, because there are two tasks that start at that node, task H and task J, and you can see they've both got different latest start time. Now, we know the latest start time for J is 38, so that's our answer for this question. But what the node actually represents is not start times, it represents the end times for the task going into that box. So it's the earliest and latest times that E, F, and K need to be finished for. So while you could finish E, F, and K at 38, and then task J will be ready to finish, and it'll get to 42, task H actually needs E, F, and K finished at 31. So when we do the diagram, we have to write 31 in that box. Because again, it's not start times, it's actually end times for the three tasks that feed into it, which I'm highlighting. E, F, and K have to be done on exactly 31. There's no wriggle room, because then they have to be finished in time for H and I to happen. You know, and while J could start earlier, J can start later, you need to get them done for H and I, so you can't wait around. So with what we just talked about in mind, we're now going to finish the entire diagrams and then talk about the critical path. So we work forwards first, as we have as usual. A, B, and C. Anything without dependence is really easy. Just write in the numbers. And then go through the graph. Usually alphabetical order is the best. 3 plus 5 is 8. 7 plus 8 is 15. 10 plus 7 is 17. So you can see the value of highlighting the lines we're doing, because we're then not forgetting to do lines and identifying changes like this. G is 8, so 10 plus 8 is 18. And see, I'm roughly working from left to right. Let's look at H next. That's 14, so that's going to be way bigger than the 8, isn't it? So 17 plus 14 is 31. And so we had 11 to 31, we're going to get 42. That's probably going to be a largest, but let's look at the others. So 18 plus 10 is 28, that's smaller. And 17 plus 11 is also 28, that's smaller too. So we've drawn our kind of forwards die. We have the earliest start times, or rather the earliest end times of each task. So now we work backwards. So we end at 42. Task I takes 11, so we take 11 away from 42, we get 31. Let's highlight task I to show that we've gone backwards down task I. For task K, that takes 10. So 42 take away 10 is 32. So you can see we can end task G at 18 hours, but we could wait all the way up until 32 hours to finish task G. So there's a lot of wiggle room in that task. You'd wait a little bit for it. Let's look at J next. That's at 11. So let's take away 11. 42 take away 11 is 31. Then let's look at H. That's 14. 31 take away 14 is going to be 17. Now, when working forwards, what the largest number in the box is, when we're working backwards, what the smallest possible numbers. We want 17 in there. If we get to that node at 31 hours, then yeah, we can start task J on time, that's fine. But then task H and J won't be done by 42 hours. So if we reduce it to 17, because task E and F absolutely have to be done by 17 hours for H and I to be done on time. Let's continue working backwards. Let's go from right to left. Let's look at D next. D's 5. So 31 take away 5 is going to give us 26. Let's look at G. That's 8. So 32 take away. So no, it's the green numbers I'm taking away. The latest times have been taken away from. 32 take away 8 is going to be 24. But then when we look at F, that's 7. So 17 take away 7 is actually 10. So we need the smallest number here. So again, you know, starting task G at 24 is absolutely fine. You know, that's going to get done in time. But you can't start task F at 24. That means that C has to be done by 10. So it's ready for task F, even though task G could wait a little bit of time. Let's look at E next. That's 8, so 17 take away 8 is 9. And then this is the diagram. And you're always going to have 0 in the first block, because one of the three alternatives will give you 0. And in this case, it's the task C is 10, and it ends in the box with 10. So we've dealt with the diagram. Now, we want the critical path. So what is the critical path? Now, the critical path is a path of tasks where there is no wiggle room. There's no waiting around. So, for example, with task A can be finished at earliest at 3 hours. But you could wait until 26 hours to finish task A. So that means that at 23 hours, you could start task A. And as long as it's done by 26, you're fine. That's not the critical path, because we have options with word start task A. We want a sequence of tasks where there are no options. And it's the boxes where the numbers are the same. So highlight those boxes, and then you highlight a path between them. So it's C, F, H, and I. That is the critical path. That sequence of tasks has to be done in order with the time shown. C has to start at 0 and end at 10. F has to start at 10 and end at 17. H has to start at 17 and end at 31. And I has to start at 31 and end at 42. There is nothing you can change there. Unlike task A, like we mentioned, where you could start it a lot later and still finish all the tasks together at 42. So that is the critical path. And it's good to mention you can also have more than one critical path. So there's only one critical path through these set of tasks. But you could have multiple routes through critical paths as well. So let's have a look at another critical path. Again, starting at 0 and add on the numbers with no dependence. So adding on D will give us 15. E gives us 24. F will give us 22. G will give us, 15 plus 14 is 19. That's less than 22, so we're safe there. H, 24 plus 6 is actually 30. Let's get rid of the 15 and write in 30. K will give us 22 plus 14 is 34, or 36 even. 30 plus 6 for I is also 36. And then add on 10 for J, 24 plus 7 is 31, which is smaller. So we've gone forward through, and the length of the critical path is 36. Now let's work backwards to find the critical path. So we start at 36. So let's go backwards. So we could take away 6 for I, which will give us 30. We can take away 14 for K, which will give us 22. We can take away 7 for J, which will give us 29. We can take away 6 for H, which will give us 26. So let's replace that. It's got to be the smallest possible number. We can take away 6 for D, which will give us 24. We can take away 13 for E, which will give us 11. And it's the same with F. 22 take away 11 is 11. We can take away 14 from 22, which will give us 8. And then one of the remaining will give us 0. And it's actually B gives us 0. 11 take away 11 is 0. The others don't give us 0. And that means they are not going to be the critical paths. The critical path is definitely going to start with the 11. Now, let's just have a look at the numbers which are the same. So we have 0 and 0, 11 and 11. We have 22 and 22. And then we have 36 and 36. Now, I can see we've got the 30 and the 30 at the top. It's not connected to anything, and it should be. And I think I've made a mistake here. So H is 6. So 30 take away 6 is actually 24. So if you ever get nodes which have the same number in both, but it doesn't actually connect properly, you've probably made a mistake like I just did. That means we've got a second critical path. So what can we say about the critical paths? Well, the first critical path that we looked at first, we went from B, we went down F, and we went down K. And that was one critical path. The other one is going down B, but then we went over to E, then H, then I. So again, there are two routes through the diagram where the numbers are the same. So all these activities have to take place at exactly the times mentioned. You can't delay one of the tasks. Yeah, we look at task C. Task C could finish at the earliest at 5, and task C could end at the latest at 8. So you've got 3 hours in which you can kind of change task C. You can start it at 0 and end at 5, or you can start it at 3 and end at 8, and you would still finish the whole thing at 36. So that's not on the critical path. Now, the next thing to talk about is a Gantt chart. And a Gantt chart is a way of organising the information about the critical path. So how does the Gantt chart work? Well, these can be drawn to scale. Now, I'm not going to draw this to scale. I'll put some numbers on so you can see. So for the Gantt chart, look at the critical path. So we've got B. Then we have F, which is actually the same size as B. They're both 11. Let's just try and line that up a bit better. And then we have K. K is a little bit bigger than those two. And so the first part of the Gantt chart, we can write on that we have task B, task F, and task K. That's a critical path. There's no wiggle room in that path. Now, a second critical path, we have B again, and E, H, and K. Now, E happens after B, so we'll start after B for E. And it's a little bit longer than F. It's 13, not 11. And then we go to H, which is 6. So 6 is a little bit shorter. And then we've got I, which is also 6. So let's label those. You'll notice I've not done B twice, I've only done it once. Now we have to put all of the letters into the chart. So what have we done so far? Well, we've done B, we've done F, we've done K, we've done E, we've done H, and we've done I. But the rest have to go in as well. So how do we do that? Well, let's have a look at A first. A has a length of 9, and it can finish at 9 or 24. So what we do is we start drawing A at the start, and we give it a length of 9. But then it can actually go as far as 24. So what we do is we actually extend the box for A to the end of 24. That was the same point as the end of E. So what we can do is we can label it A, but then we have this kind of dotted line section at the end, which represents how far forward A can slide. So while B, F, K, E, H, and I are all part of the critical path and can't move, we can see how A can slide from the position it's in at the moment all the way up to where 24 is, and ending at 24. So that's A done. So now let's have a look at C. And C is going to work the same way. I'm going to start at the start, have a width of 5. Let's label C. But C could go as late as 8. So what we can do is extend the box to 8, like this. And we're going to have a dotted line around that as well. Then we can see that C can slide forward a little bit, not too much though. So now let's cross out C. Let's look at D next. Now D can start when A finishes, which is at 9 at the earliest. So we'll start drawing a box for D there. I'll do it about the size of 6s. Let's label it. However, D could finish as late as 30. So what we can do is we can extend D all the way up to 30, make sure it's a dotted line around it. And what we can do here is we can see how far forward D can slide. Now you might be thinking, why are we doing this diagram? What's the point of it? Well, it's kind of telling you how many people you need to do these tasks. So we've got 2 critical paths. We need 2 employees to do BFK, and that's going to fill up 1 employee's entire day. And then with EHI, we need a second employee for that. But you can see that C will actually fit into the gap before E. So an employee could do task C and then do E, H, and I. And then you can see with A and D can fit in together. You could do task D right after task A, and 1 employee could do both tasks. So it's just a way of kind of organising labour. So we've done D. So what else do we need? So we need someone needs to do task G. Now task G starts at 5, so that was after task C, and it's got a length of 14, but it can go up as late as 22, so we can extend it slightly. Now do you know that I'm not drawing this to scale, it's just kind of a sketch, you can get the idea of it, but if this was drawn to scale, you will be able to see exactly where this task could fit in. So it could be that the employee who does task C could then do task G next, or the employee does task C could do E, H, and I, but they can't do both because you can see that C and G won't fit in that gap together. That's task G done. We've got 1 left, and it's task J. Now, task J, it can start at 24, and it takes 7, and it can end as late as 36. It's going to look something like this. Make sure you do a dotted line around it to show that it's optional, and we'll have to label it. And that's all the tasks done. And then what you could do with the Gantt chart is that you could start merging the columns together. So BFK, that's from the start to the end, so you can't do anything with that. But you could do something like, you know, employee C could fit in the gap before E, H, and I. It could be that 1 employee does A, D, and then J. And maybe to even fit things around, we could maybe just about fit G after D and do A, then D, then slide G across and do G, and then do J. And it was drawn to scale, you could fit it all together, and perhaps you get away with 3 employees for this job. But that's the Gantt chart. So the critical path at the top, and then we have all the tasks that are not critical and have optional kind of room where they could start a little bit later if you needed them to. And then you can see all the ways they fit together. So you don't need, you know, how many lines are here? 1, 2, 3, 4, 5, 6, 7. You could do this with 7 employees, but you can see gaps, we can fit them together and use less than 7 people to do all the tasks. Now let's look at one more example. So we can find the first part really easily. The ones with no dependents, starting at 0. Add on D, so 13 plus 14 is 27. Add on E, 12 plus 12 is 24. Now we're going to have F, 7 plus 15 is 22. So the 24 is fine. But then the 10 for H, 24 plus 10 is actually 34. So we need to get rid of the 27. It's going to be 34. So again, we're using a pencil for this. Add on 13 for G will leave us with 20. Then added on 5 for K will give us 25. Now I've made a mistake here because I'm now going to have to redo everything after this node. That's 25. So adding 10 to it will actually give us 35. Then we can add on 14 to 35, which will give us 49. Adding on 10 to 25 gives 35. That's smaller, so our diagram is complete. So now work backwards through it. We'll start with 49. We can take away 14 from 49, which will give us 35. Looks like we found a critical path here. 35 take away 14 for path D will give us 21. So it looks like D is not going to be a critical path. 35 take away 10 is 25. Now what I'm not doing here is highlighting the path, so I'm not missing any out. So with J, 49 take away 10 is 39. That's larger than 25. so we'll not do that. Now I'm trying to work from the right to the left. Let's do K next. Let's take away 5. It was 20. And then 20, take away 13, give us 7. So it definitely looks like we found a critical path there. Let's check F. 25 take away 15 is 10. That's larger. 25 take away 12 will be 13. And then at the end, we're going to have 0. And where does that come from? Well, it's come from C. 7 take away 7 is 0. So the other two paths are not going to be critical paths. Let's highlight all the numbers where the same number twice. 0, 0, 7, 7. 25, 25, 20, 20, 35, 35, and 49, 49. We have to be really, really careful with the path through this. So we're set at 0, 0, and we're going to 7, 7, adding on 7. Now you might be tempted to go down F. Now it's 7 plus the 15 for F is 22. That doesn't get us to the 25, so we're going around F. We're going in this direction. And again, 25, you might be tempted to go to 49 straight away. But adding on 10 will get us to 35. So actually we can't go down J. We've got to go up and around like this. So when you draw a critical path, don't just randomly join up any nodes where they've got the same number twice. Actually make sure you actually get to that number by going down the node, because there might be options. And now we've got a final answer for the critical path. We're going from C to G to K to H to I, and that is a critical path. Now there's one more thing you might be asked to do. You might be asked to actually allocate time to employees to do all of these tasks. So let's call this an activity diagram. So how do we do this? Well, the first thing we do is similar to a Gantt chart. It's actually easier to do an activity diagram after doing a Gantt chart, actually. But what you would do, you say, well, C. We've got 7 Cs. So we'd write out C 7 times. Then we've got G, which is 13 Gs. Then we've got 5 Ks. We've got 10 H's. And then we've got 14 Is. So you'd have something like this. It just shows the kind of 49, let's say, hours for this time unit. 49 hours of work that perhaps one employee could be doing all in a row. So you start up with a critical path. Once you've done the critical path, we have to fit in the rest of the tasks. So we've done C and G and K and H and I. So let's look at A. Now there's 13 A's. So let's start with the start. Notice I'm lining it all up. Then after task A, you can fit in task D. There's 14 of those. Then what can we fit in after that? Well, we need task B doing as well. Now task B, you can see it can finish at 13 or it can finish at 12. So what we could do, we could actually start task B 1 and leave a gap at the start. Now you want to kind of avoid doing that. Could have done that with A as well and left a gap of 7 at the start if they ever wanted to. But you're trying to kind of fit all the time in efficiently. So usually doing that's not going to be helpful. And since B is the last one I'm doing at towards the start, then I know I can actually put it a little bit later if I need to. Then we've got E, there's 12 of those. And you can see that E finishes just before H starts in the top column because H is dependent on E. So you have to kind of follow the rules of things that are dependent on each other. You can't start things later on. D has to finish before I starts, for example, and you can see there is like a space there. There's enough room for D to finish. So we've done E. After E, we could do J, and that's got 10 units. Now we could start this just before the end if maybe we could fit something else in, but I don't think that's going to be the case, so I can just start J straight away. So we can see a big gap at the end, so you could move J further forward. Perhaps you want to give an employee a break. You know, you could put gaps in. That could be something to consider as well. So it all depends on the context of what you're doing. Now, what else do we have left? We've only got one thing left, and that's F. Now, F has to start 7 in, so I can't start F right at the start. I've got to wait for 7 after C finishes. It's a 7 off to start here, and there's 15 of them. So if you wanted to set the time efficiently, what you'd probably want to do is try and fit F in to one of the columns above. Now, it can't fit in the one with the B, the E, and the J. It could maybe fit in with the one with the A's. Now, with A, we could delay A 7 later, but that'll make it overlap even more with F. We could delay F. Now, F has to finish at 25, which is where H starts. So we shift F forward maybe about 3-4 places. That's not enough to fit it into that second column. So it looks like, with the activity diagram, this is going to require 4 employees. Okay, the big thing here is to be drawn to scale, so each letter has to be lined up in a column. You'll be given a grid to put this into. You have to do it. And it probably won't be as wide as 49, so you probably have a little bit of an easier time than I just did. And also, you'll usually want to do a Gantt chart before the activity diagram, so you can visualize better where each task could potentially go with the Gantt diagram. So then for the activity diagram, you can have a go at allocating the time. And there may be multiple answers for this. So again, you know, the A's and the D's could shift forward by 7 places, for example. So there will be a range of answers for these diagrams. But the important thing is going to be that if it requires 4 employees, you can't go over 4. You've got to try and fit everything in.
Ouch. Love you too, Crim.